This is a demonstration of using imagery in ArcMap. So we're just going to work with a bit of Landsat satellite imagery, and I'll give you a brief demonstration of how this all works. Okay, so we'll start off by looking at my geodatabase over here in the catalog pane, and you'll see that I have 8 different bands of Landsat data. So I can just take one of those, for example band 4, which is the near infrared, drag that onto ArcMap, and it will display it. But you'll notice that it's really hard to see anything. That's because the actual range of cell numbers in this data set is fairly small, and it's not displaying at the full range of possible values from, say, black to white that the monitor is capable of displaying. So the easiest thing to do to start with is we can go into the properties and the symbology and use things called stretches. So for example, we can use a standard deviation stretch, and what this will essentially do, there's various ways to do this, but it will take the small range of values that are actually stored in the image and stretch them out across the full range of display values from black to white. And if we apply this, you'll notice that suddenly I have an image that has a lot more information for me to be able to view than I had before. Nothing's changed in the actual data file, it's just the way that it's being displayed. So I'll click OK, and so now I can explore my image. For example, I can zoom in here, I can look at, say, this area here, and use things like the Identify tool to look at what the actual cell values are for different types of land cover. So here, for example, you'll see I clicked on the water, and the actual pixel value in band 4, which is near infrared, is 9, which is quite low out of a possible range of 0 to 255. The stretched value is 42. That means that it's actually being displayed as though it was a value of 42, but the real original data value is 9. That's because near infrared light is absorbed by water, and so not very much of it is reflected. If I click on something that's quite bright in the image, you'll notice that it has a much higher pixel value than we had before. So the Identify tool is an amazing, it's a simple tool, but it's great for being able to get a sense of what different land cover types, how they respond or reflect light in various different bands. So you can look at different bands and see how it reflects values, or gives you those values. If we wanted to, we can look at more than one band at a time, so we can create a composite of more than one band. So there's a tool that I can use for this. If I just search for band composite here, you'll see that I get composite bands is the name of the tool, and I can browse to my data set, and if I wanted to, which I'll do here, I can add all 8 bands. And what I'm going to do essentially with this is create a new image, or sorry, a new file that stores all of these in a new file format. So sometimes it's easier to work with. I'm going to store this outside of my geodatabase and just call it Vancouver.img, which is an URDAS Imagine format that allows you to have more than one band in the same file, and sometimes it's a useful one to work with. So if I click OK, it's going to take all of that original imagery, which right now are being stored as separate rasters in my geodatabase, and put it into a new file that's an URDAS Imagine format. And why would I want to do this? Well, I'll show you here. If you look in the table of contents, you'll now notice that I have I'm showing 3 different bands at the same time. One's being shown with red light on the monitor, one with green light, one with blue light. Those are not the wavelengths that were sensed by the satellite. These are the display colors that are used by the monitor. And if I left click on, say, the red box, I can select a different band. So if I wanted to create a natural color image, I would assign the red light on the monitor to the red light that was sensed from the satellite, green to green, and blue to blue. And so if I zoom out here, this now gives us a natural color image of Vancouver, as though we were, say, looking at it with our naked eyes floating above the Earth, or if we took a picture with a regular camera. But the great thing, of course, is that we can use other kinds of combinations, such as using light that we can't see with a visible eye, such as the near infrared. So a very popular and traditional combination is 4, 3, and 2. that's near infrared, red, and green being assigned to red, green, and blue. And this mimics the appearance of false color infrared film that was used years ago, but it's still used because by convention people are used to seeing it that way. And in this, the more vegetation there is, the brighter red the image will look, because vegetation reflects near infrared light very well. And contrary, the water absorbs near infrared light quite a bit. So the areas that are quite dark are areas of water. The areas that are bright red are vegetation, and we have all kinds of other combinations in between. So we can use this to zoom in again. If we go back to the same area we were looking at a minute ago, you can see this area in the middle here, Stanley Park, is bright red because it's well forested. Okay, we can also look at other combinations. If I zoom out again, another popular one is 453, so we'll leave that one as 4. Green will make 5, and blue will go to 3. And this is very useful for being able to see other kinds of land cover. So there's not necessarily one that's right or wrong. They're good for different purposes, and there's lots of different combinations you can try. These are just ones that are very commonly used. Okay, so something else we can do is add our thermal infrared, which is band 6. And what I'm going to do here is assign this to something that would look like thermal, which, let's say it's sort of red to blue, and we'll invert that so we have the proper assignment there. Oh, and I forgot to enhance it or stretch it. So now we have this actually showing emitted light, or sort of emitted energy related to surface temperature, and you can see the urbanized areas are much warmer, and the water in the mountainous areas are much cooler. So we can show images in different ways. We don't just have to use black and white. We don't just have to use a composite. Now, if I want to, I can open up the image analysis window, which is an amazing little tool that Esri has included in ArcMap. And for example, I can create, if I add band 3 to my image, so now I now have band 3 and 4 loaded. Those just happen to be the bands that are used by the Normalized Difference Vegetation Index, NDVI. So in the image analysis window, you have to select the images that you want to do something to. So in this case, I'm going to select band 3 and 4, and you'll notice that under processing, a little green maple leaf has been highlighted, and I can use that to create an NDVI image. And so this is an amazing little tool where the greener the image, the more vegetation there is. The yellow is less vegetation, and the red is less again. So we have this really nice indicator of how much vegetation is present in our satellite image. So if we, for example, wanted to compare this to our thermal image, and you'll notice, by the way, that the NDVI function has created a new temporary image that's been added to our display. So now if I select NDVI, and then actually I will zoom to the pixel display resolution, which in other words means that one cell in the satellite image is being displayed as 1 pixel on the screen. So this gives us a nice size. Basically, if you zoom in any farther than this, you're not going to get any additional information. But if we do this, then I can use the swipe tool to compare my NDVI to something underneath. So in this case, we have the thermal band underneath, and the swipe tool can be used to compare information between 2 different images. So here, for example, I might be interested in exploring if there's a relationship between amount of vegetation and surface temperature. So I can swipe back and forth to see if I can see any relationship between those two. You can also swipe top to bottom if you want, and you can use this with any combination, so it's a really handy little tool. Another tool we can use in the image analysis window is pan sharpening. So if I add band 8, which is the panchromatic band, and then select that with my composite, let's just turn off, well, here's my band 8, which is a higher spatial resolution. We'll turn off the NDVI and thermal. And so now if I, let's just go into the 1:1 resolution like we have, and if I do a pan sharpening, which means I'm going to select band 8 and my composite and select the pan sharpen tool, this is going to assign the multispectral data to the panchromatic image, which is at a higher resolution, create a new version. And if I set that to, say, 4, 3, and 2, what we now have is something that's got the information from our multispectral data attached to or integrated into the panchromatic image, which is at a higher spatial resolution. And now if I select that and zoom in to a 1:1 display, I'm actually able to zoom in farther because we're at a higher spatial resolution. We can see more detail than we would have been able to see without the pen sharpening. So for example, if I do my swipe between the pan sharpened version and the original composite, you'll notice that, well, actually, let me just, sorry about that, let me make sure we're looking at the same combination here, 4, 3, and 2 in both. There we go. And so now you can see that I'm swiping, the pan sharpened version is on top, which you'll see on the right, and the original version is on the left, and you're getting less detail with the original version and more detail with the pan sharpened version. That's the whole point of pan sharpening. That's about it for this demo. I just wanted to give you a quick introduction to loading and viewing and having a quick look at analysis of satellite imagery in ArcMap.